Right, it is 9 o'clock, so I'm going to get started. The midterm is finally all graded. Okay, it took me a bit of time. I can grade about 2 questions, and then have to take a nap. It's really straining to grade midterms. For whatever reason, I don't know exactly why, but it was really straining for me to grade the midterm. But it's all graded. If you go to your grade book, you can check your grade. I think as a class, I think the class did pretty good in general. Okay. Not sure whether I turned on the ranking for this class. If I have not, you guys can remind me to do so. The ranking doesn't really change anything. I'm not going to grade by curve in any way, okay? But it does give you a sense of how you compare to your peers, if you care, okay? So it's not something that is really important. Ranking is only useful in situations like you don't quite know where you stand in the class. Am I falling behind the class? Am I catching up with the class? Am I about the same place where everybody else is? So it's only useful for that purpose. But as far as grading is concerned, it is not that useful. If everybody can meet my expectation of being an A student, the whole class can get A's in this class. Okay. All right. So having said that, the first thing we'll do is to go do the homework assignment. Okay. I'm hoping that most of you remember that there's a homework assignment due today, okay? And some of you I know have turned it in like a long time ago, okay? You got it done in the previous class already. And the homework assignment is this one. It's for finding a prime factor given a particular number. And so what we'll do today, or what I will do today at the beginning of this class, is not only to give you the solution, because that won't take long, okay, but I do want to kind of explain the process of how to write a program, how to put things together. All right. So are there any questions before we move on and talk about the solution for the homework assignment? Okay. No particular questions? Okay. No particular requests like, please, don't go over this homework assignment. It is so easy. I don't want to waste any time on it. Does anyone want to complain about that? No? Okay. So if there are no complaints, no objection, I'm going to talk about the solution. So what we'll do is we'll start with what the subroutine is supposed to do first, okay? Which is very, very important, because a lot of times people find it's difficult to write any code because they don't quite know what a subroutine is supposed to do to begin with. Okay. This particular subroutine, okay, according to this part here, is going to find a prime factor of the parameter x and store it in factor as a local variable. You don't have to modify any of the code here. In other words, you can keep the local variable factor here, and you can keep the return statement here. All you have to do is to find the prime factor of the parameter x, which is here, and store it in factor, and it will be returned because of the code that I put at the end of the subroutine. So your focus is really just the algorithm to find the prime factor. That's it. Okay. For those of you who remember the spreadsheet, do you guys still remember the spreadsheet? I basically retry, with potential factors, starting with 2. If 2 doesn't work, I go to 3. If 3 doesn't work, I go to 4, which does not seem to a very good idea. Okay, it's not a good idea because 4 is 2 times 2. If I know that 2 is not a factor, 4 cannot possibly be a factor. But that saves me the trouble of only focusing on prime numbers, because I don't have any way to store prime numbers at this point. Okay, we don't have any arrays, we don't have any other ways to get the prime numbers. So testing 4 as a potential factor is not a problem, because there's no way the algorithm will mistakenly say, hey, you know what, 2 is not a factor, but 4 is. The math just does not work out that way. So I will test 4 and then 5 and so on until I find a number that is a factor of the given number x. And efficiency is not a big deal here. Okay, I'm not going to ask you for the most optimal way to do it. So any way you can do this is going to be okay, as long as your program can return a particular prime factor of a number. So are there any questions about what the subroutine is supposed to do, or what the algorithm that you had to write is supposed to do? No questions? Okay. So what we'll do, or what I'll do, is I'm going to put together a program, but in steps, okay? In other words, the important part is not to do it all in one shot, but do it in steps. Okay. I'm not gonna bother with creating a subfolder and stuff like that, so I'll just go ahead and write the code here. So let's see, I'm gonna make this as long as, not as long as possible, because I still need to make sure that you guys can read at the bottom part here. Okay, there we go. And it's supposed to call main.cpp, and there we go. And I'll just go ahead and copy and paste the rest of the code here. Let's copy. Oops. The paste is not going to work very well because of auto indent. In fact, I'm going to turn it off first. Set no auto indent. Insert, paste, and then turn it back on. And then we have all the leading spaces. I'm gonna get rid of all those first. 1, 2, 3, 4. Go. All right. So I have the same starting point as you should get for your homework assignment. And the first thing I need to think about is, okay, how do I do it by hand? Okay. Now, if you remember from the spreadsheet, when you do it by hand, what type of control structure do you think you should think about when we did it by hand? I'll give you 2 choices here. Well, 3. The first one is just a sequence, okay? Just a whole bunch of assignment statements, and that's it. The second one is a conditional statement, okay? Or a bunch of conditional statements that can be embedded into each other. And the third one is a loop. Which one do you think is the most appropriate? A loop? Now, how can you tell or decide that a loop is probably the best choice here? There's repetition, okay? Yeah, because if nothing else, the spreadsheet should convince you that we're doing something over and over again, okay? So that means we need some kind of a loop here. The way I do this is I usually just say there's a loop of some kind, okay? Because I don't know what kind of a loop we're dealing with here yet, okay? And this is not actual C code. I'm just, this is pseudo C code because C does not have the word loop, okay? And exit has a different meaning. But I'm just putting this in to remind myself that we're dealing with a loop here. How many different types of loops have we talked about in this class? 2.5, right? 2.5, because there's a do while loop, which is the only way to do a post checking. And then we have 2 ways, sort of 1.5 ways to do the pre-checking loop. The most basic one is called a while loop, okay, because it's really simple. You specify the condition that has to be true in order to stay in the loop, and there's a pre-checking loop. You check the condition, then it performs one operation if the condition is true, and then you go back and check again. And then the other one is the fancy version of a while loop, and it's called a for loop, okay? But a for loop, everything you can do with a while loop, you can do it with a for loop, and vice versa. And that's why I consider one or the other one as the half, and that's why we only have 2.5 types of loops in C and C++ programming. Okay, the only difference is you have to choose, are we checking the condition first, or are we checking the condition after we perform an operation? And I'm not too concerned about that at this point, okay? I'm much more concerned about, hey, when do we get out of a loop? Now, there are 2 ways to look at the condition too. You can look at the condition as an exit condition, which means when are we getting out of a loop, or you can see it as a stay in loop condition, which is what a while condition is. Okay, it's when do we stay in the loop? I personally like to think about exit condition, which means, okay, when I get out of this loop, this has to be true. Okay, which makes more sense to some people, but it's equivalent to the negation of a stay in loop condition. So either way, it's okay. It all depends on which one you feel more comfortable with. When do I get out? In other words, when am I done? And say, okay, I'm all done here. But what is the condition? What is the condition that says I'm done here? What is quote unquote done? Okay, so it seems like we have found a factor, right?
Yeah.
We have found a factor is a good way to describe it. Okay, fine. We'll just say we have found a factor. Okay, that is obviously not C code, right? If you try to put this program in and compile the program, the compiler would have a hard time understanding what we are talking about here. It will spew out pages after pages of errors. Okay, but it's good for me to take a look at this and go like, okay, at least we know the control structure is a while loop, and we have kind of identified what should be inside the condition. Okay, it's the negation of what we really want, but that's easy, okay, because the negation is just an exclamation point. All right, is there a better way to say, we have a factor of what?
X.
Of x. Very good. Okay, so we are trying to be more specific now. Okay, very good. We have found a factor of x. How should I call this factor? Can I just call that factor as a local variable? Sure I can, right?
Yeah.
Why not? Because it is what I'm going to return afterwards, so we can just say the factor is just called factor as a local variable. So now the question is, how can I confirm factor as a local variable is in fact a factor of parameter x? How can I confirm that? Now, how do you confirm that in a normal arithmetic situation? If I give you 19 and I give you 5, how do you know whether 5 is a factor of 19 or not? You divide it, and then you take a look at what? The quotient? The remainder, right? Okay, so how do we get to the remainder in C and C++? The mod operator, which looks like a... Exactly, it's the percent symbol. Okay, all right, so we know that this has something to do with this expression here, okay? So I'm gonna take this out and say, in order to determine that, we know that we are dealing with x mod factor in one form or another, okay? This expression is important because it gives us the remainder of x divided by factor. Okay, now, since I'm dealing with an exit condition here and not a stay in loop condition, what do I want the remainder of x divided by factor in order to say, oh, this factor is in fact a factor of x and I can now get out of the loop? I want it to be a 0. Very good. Okay. So I'm going to say compare that to 0. If it is 0, let's get out of the loop. Okay. Are we still doing okay so far? So at this point, I cannot test the program at all because this is not actual C code. But I'm evolving the algorithm by just thinking it out. Okay, you're trying to put in more details as we can get into the code here. Okay. All right. So now we have a loop. We know the exit condition is when the remainder of x divided by factor is in fact 0. Okay, so far so good. But since we have a loop, then you have to think about two more things. Okay, you have to think about two more things. One is the conditions or the state of the variables before we get into the loop, which is also called the initialization. And the other one is what are we doing to at least one of these two variables in the loop. Okay, so those are the two additional questions you have to ask. In other words, since we know we're dealing with a loop here, we have to say, okay, what do we have to do the initialization? And what are we doing on a per step basis? Okay, because those two components are usually very important when you're dealing with a loop. Now, in the case of an initialization, we know that it has to do with some kind of variable that we are dealing with here. Should I change x in the initialization? Can I just simplify the problem and say 2 is a factor of 2 and I'm done, right? Because the caller just wants to know a factor of some number, right? Can I change the number and say, well, I'm going to change the problem? Can't do that, right? So the only thing you can initialize is factor. Okay, so okay. But how should I initialize factor?
Depends if you're doing a for loop.
Sorry?
Are you doing a for loop?
Depends on the loop. Okay. So what is the first factor that I should try? 2. Okay, so maybe I should just go ahead and initialize it to 2, since it is the first factor that I should try. Okay. So what about the step in the loop here? In other words, assuming it's not time to get out of the loop, which means x mod factor is non-zero, what am I going to do? How do I get to the next potential factor?
Increase the value of the factor.
Just increase factor by
By what?
by 1, exactly. And there are many ways to specify this. I'll just use one of the easier ones. Okay, it saves me some typing, but it's really nothing more than factor equals factor plus 1. Okay, it's just a really shorthand version of that. Okay. All right. So now I got all of these done. I can now go back here and say, well, it's kind of a bummer that we don't have a loop exit when blah 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 blah. We do have a while loop here, but this is not going to work with a while loop, because a while loop wants to keep inside the loop when the condition is true, not when it is false. Okay, so what do I need to do about the condition to basically say, as long as I have not found a factor, stay in the loop?
Doesn't equal 0.
Does not equal to 0, exactly. So as long as factor is not actually a factor, which means the remainder of the division is not 0, stay in the loop. And then for each iteration of the loop, I'm just going to increase factor by 1, and then test it again. If it doesn't work, increase it by another 1, test it again, and so on. Okay, so that's the general idea of how to put something together. The other thing you can also consider, if you're having a hard time getting started with an algorithm, is to put all the ingredients that you think are, involved into the program, and then think about how to organize those things. Because I think most of you recognize that mod is important. You know this is some kind of a loop, okay? But the only place the mod can really go into is the condition part, because it is used to check whether it's time to get out or not. Okay. So are there any other questions about the solution? Now, if your code, is longer or shorter than this, as long as it works, it will still be okay. I don't know of any shorter ways of doing it using a while loop. You can kind of shorten the loop using a for loop. I can give you the version of a for loop. A for loop is really, okay, if you use a for loop and you really want to go for, like the shortest possible way to do it, then you can say initialization goes here, factor is 2. That's a single equal because it's initialization, and then the condition stays the same. And you can shorten the condition to just x mod factor, because if it is non-zero, it is automatically true. So there's no need to compare it to 0. And then, well, you can even combine the post operation into here and just make this an empty statement. So this is the quote-unquote shortest way I can write it in C and C++ code. Line 15 all by itself is the solution. Now, I'm not suggesting that you guys should write code, that terse, okay, because that usually makes code a little bit harder to read. But even if you're not writing code that terse, you should understand that this line 15 all by itself is the same as line 9 all the way to line 14. So that, if you don't really quite see how they're the same, you have to kind of think about it, read up on, what a for loop is, and to make sure that you actually understand that line 9 all the way to line 14, that chunk of code, is really just line 15 all by itself. Are there any questions about that? No questions? I only have to keep one of those two. Yep, go ahead.
For the for loop, when you say x mod factor, where's the condition?
Well, okay, x mod factor is an integer, right? Because you're taking the remainder of an integer divided by an integer. Is that right?
Yeah.
And an integer can be 0 or non-zero, right? And anything that is either 0 or non-zero can be interpreted as a condition in C and C++. So that's why whether you compare that to 0 or not really doesn't matter, because if the remainder is non-zero, then it is saying the same thing as it is non-zero, as it's the same as on line 10 where you compare it to 0 explicitly and say, is it different from 0?
Thank you.
Yep. But that's a good question, and I just want to make sure that the entire class understands that the condition of line 10 and the condition of line 15 are equivalent. It's just that on line 15, I chose to make it very short and not intuitive. Whereas on line 10, it is more intuitive, but the comparison to 0 is actually not necessary. All right. Well, I'm going to comment out a chunk of this code here. The more spelled out version, I'm going to comment out that particular one because I want to test line 15. Is it really that short? Does it work? So that's what I'm going to test. Are there any questions before I get out of the editor and actually test out the code? Yep.
Just after line 15, we don't have any body for the Boolean line.
That is true because the post operation plus factor is doing everything that I need to do for each iteration. So there's nothing else to specify.
Okay, because it's like the opposite. Since if you have a reminder, then it will just go back to the loop. If you don't have a reminder, it will just return factor.
If there is a remainder, it will perform the statement of the loop, which is an empty statement, right? There's still a statement, it's just an empty statement.
Yeah,
and then there's the post operation, which is plus factor. And then it will go back and check the condition again. So functionally speaking, it is doing the same thing as the longer version above it, but it is a kind of really terse version of the same thing. Okay? As I said, I'm not going to test you guys and say, write the shortest possible code to do something, because that really is not usually a very good idea. On the other hand, if I give you line 15, you should understand that it is the same as the longer version, which is right above it. All right, if there are no questions, are there any other additional questions about the code on the projector right now? Okay, no other questions. So if there are no other questions, I'm going to get out of the editor and actually give it a try, right? And how do we know this is working or not? Okay. G++-C-G. We'll do a warn all, why not? And this is main CPP. So this will give me a .o file. This is a normal complaint. We know about this one already. And then we'll go ahead and link the program using -o to specify the executable file name and main.o as the input to the linker. And the only way to debug this program is to go through GDB because it does not actually print anything. Okay, so you go into GDB, put a breakpoint in main, run the program. Now we're at a breakpoint. Now that we're at a breakpoint, we can just go ahead and print. Find factor. Let's try 3. Okay. Gives me 3, which is correct. 2 is one of the boundary cases. I think I talked about this in class already because it is the smallest prime number, so you should always try it too. We can try 4. It is the prime factor of 4 is 2. Okay, that's good. Try 26. It will return 2 and not 13 because this is testing from small numbers to large numbers, so we will naturally report the smallest prime factor and not the largest. 49 is a square of 7, so it should just report 7. 41 itself is a prime number. It should go all the way to 41 and come back with 41 as the answer. So it does test out, does work for all of these cases, which is pretty much what I need is to test all of these cases only. Are there any questions about this particular program? No questions? All right. If there are no questions, I'm going to pass the row sheet. Today is the last column of this row sheet. So there you go. And this is a good time to get started with a new homework assignment. The new homework assignment is about reading and writing, okay, in particularly reading in this case. So if you go to input and output using files, this is where you'll find the new homework assignment. The new homework assignment is called Read a Number with Error Checking and Recovery, okay. So this one is kind of tricky because you have to first understand what the program is supposed to do, and I kind of try my best to illustrate what the program is supposed to do, and we'll talk about it in class too. So in this program, you'll write a subroutine. So you have to write a particular subroutine to read a number from the standard input file, okay, which is already open. Your program is ready to read that file as soon as it starts. You have to check for error and recover from any error that it might detect. To start, create a subfolder called readnum, case sensitive, in the home directory. Change directory into readnum, and then write your program in main.cpp. You know, they're all case sensitive. None of this really has changed from the previous homework assignments, other than the name of the folder. And this is a template. Okay, you know, it starts with include stdio.h, and the rest of the program is kind of, you know, given to you. This is the only part where you have to make any changes. The main program or the main function is kind of done already. I will explain what it does, but you know, this is the only place you have to put in your code. If anyone feels like, you know, writing additional subroutines, you know, and call your subroutine from readnum, you can do that. You know, it's a good idea to break a bigger subroutine down into smaller ones, but you don't have to do that. All right. So I'll just go ahead and briefly explain what main is doing. Okay. So what main is doing is it has a do-while loop. This is one of the very rare occasions where you have a post-checking loop instead of a pre-checking loop. The reason why this is a post-checking loop is I cannot test the condition to go out until I have attempted to read a number. Okay, so that's why it's a post-checking loop. The do loop has its own local variable x here, and x is the result of calling readnum. Okay, so I will store the return value of readnum into x first. And then the first thing I will do is to test whether it is the end of file of standard input file. FEOF is end of file. Okay, so whatever you specify in the parentheses is, okay, you want me to check whether it's end of file, but which file are we dealing with? In this case, it's the standard input file. I'm hoping you still remember the analogy of the input file is kind of like a conveyor belt into the plant. So this means, you know, okay, is this all to the input conveyor belt? Okay, because there is a flag to indicate, oh, yep, that's all. Okay, we'll talk about that later as well. If it is not the end of file after readnum, then readnum must have read an integer. Okay, so I just want to print it out. Okay, so I use x as a parameter to printf. And in the format string of printf, I specify %d because I want to print it out as a base 10 integer, and the line feed character here, so I can, you know, keep doing this as long as I have integers in the standard input file. It will keep, you know, printing or echoing the integers to the output. So I'll keep doing this. Okay, this is the outside of the while loop here, and until I am at the end of file, because I stay in the loop as long as it is not the end of file, which basically means I'm going to get out of the loop when I have reached the end of file. Is that okay so far? Sort of? Maybe not?
Have you have any example of that?
Sorry?
Have you have any example?
Yes, I will give you some examples, additional examples as well. Okay, so there's more to the description. Okay, you don't have to touch the main function. FEOF stdin means reach the end of file of standard input file. Okay, so this is all the stuff that I have talked about already. Your code can only make use of scanf, FEOF, and any subroutine that you write. Okay, so you cannot call any other subroutines. You cannot use any global variables. I really doubt that you need one. But you can introduce and use as many local variables as you need. If you write additional subroutines, they can use any number of parameters and or local variables. You can use any control structure and operators in this assignment. So there's no restriction whatsoever as far as control structure and operators are concerned. If you want to use ternary operator, go ahead. If you want to use mod, go ahead. Bitwise operators, if you think you need it, okay, go ahead and use it. Okay, I don't think you'll need a whole lot of operators in this particular case. Okay, so there's a lot more coming, you know, to describe, you know, readnum itself. The readnum function is going to be a little bit tricky. It has to read a base 10 number using scanf. Okay, in the previous class, we talked about this already. Okay, we talked about exactly that. When you read using scanf, you have to supply a format string, just like with printf. Okay, it's the same standard. So to read a base 10 number, you have to specify %d. Okay, and say, okay, I'm reading a base 10 integer, and use %d to specify that. We'll talk about all that later as well today. However, it also needs to detect input errors and recover from the input errors. Okay, so what if I give you something that cannot be understood as an integer? Okay, in other words, what if I give you, or what if I present to the program something like A, B, C, D, and try to read it in as an integer, as a base 10 integer? This is okay as hexadecimal, but it's not base 10 at all. So what scanf will do is it will look at the first letter, the first character, and go like, oh, that is not a good start for a base 10 integer, and it will just come back and say, no, cannot read it as a base 10 integer. That's all it's going to say. Okay, it won't even attempt, it won't even read the actual character. It will just leave it there and say this is not the starting point of a base 10 number. It will just leave it at that. Okay, I'll illustrate all of this later on. So the trick is to rely on scanf, reading the man page of scanf. Okay, and you guys all have access to the man page. Just go to any command prompt in a virtual machine and say man scanf, and that will give you what we call the man page, or the manual page of scanf. Now, I know this is really kind of heavy duty reading, but if you skip all the way to the return value part, okay, these functions return the number of input items successfully matched or parsed, if you will, and assigned, which means it is stored as a result, which can be fewer than provided for, or even 0 in the event of early matching failure. So that means if your scanf is attempting to read a single integer in base 10 and is returning 0, what does it mean? It could not read it, right? So that use the return value of scanf as an indication of whether the read operation itself was successful or not. That's your error detection mechanism. But once you detect an error, you have to recover from the error. So the next part of the slide, or the homework description, shows you how to recover from an error. So to recover from an error, readnum needs to dispose of the character that is not what it expects. Okay, so that means if I have A, B, C, D, and then eventually a base 10 number, let's say 100 here, I need to dispose of this A here because A is not the beginning of a base 10 number. Okay, fine. We'll use a particular mechanism to dispose of it. So let's say A is gone, and now the program is attempting to read this as the beginning of a base 10 number. Of course, that's not going to work either, right? Get rid of this one, move on to the next one, not going to work. Move on to the next one, not going to work. Move on to the next one. Ah, this is okay. And in fact, scanf will read as many characters as possible and interpret it as a single base 10 number. So in this case, it will read 100. So let's say we have some more gibberish after this, like pound sign over at this point. So it will read 100 and say, aha, we got a base 10 number. And then it will stop here and say, well, we don't know what it is. I don't care either, because I was only told to read a base 10 number, and I will read 100 as a base 10 number to represent the value of 100. Are we doing okay so far with this concept? What is the difference between 100 and 100? 100 means literally the digits, the characters, 100. 100 is a value. A value versus a number, I don't see the difference. Okay, this is a person. Tag is a name of this person. Okay, same thing. 100 is the name of, is a value. 100 is a particular name for that value. Is that okay? Sort of? Okay. Okay, so I'll illustrate all of these later on today. I just want to describe the homework assignment first. So what do we need to do to dispose of A, B, C, D, in this case, the one on the whiteboard? This is how you do it, okay? So what we do is we declare, this is the first time we see the type char, which is character, okay? A character is kind of like an 8-bit integer. In other words, it's kind of like a really, really short integer. But it also has a special property, okay? Because when you're dealing with a text file, a character, which is a byte, is the quantum of a regular text file. And that's why it has a special use here. When we use scanf %c, not %d, this is not a typo, okay? It means I'm trying to read a single character, not an integer. So if you try to read a single character, it will just give you one single character. If I'm at this point already, when I'm just about to read 100, and I use this instead of %d, it will read in just the 1 as a character into ch as a variable. It's not going to read the 0, the other 2 zeros. Okay, so I'm going to illustrate all of this later on so that you have all the basic building blocks of your homework assignment. You kind of have to think about how to put everything together, but I will give you all the components and illustrate how each component works. And then you have to kind of think about, okay, but how do I connect this with the next one so that the program as a whole is doing what it is supposed to? Okay. So I just explained what the next paragraph is talking about. There's one stop condition that readnum must detect, and that is when there's nothing left in the input file. In other words, FEOF SDDIN. Okay, so I will illustrate that later on as well in this class. And that's pretty much what readnum is supposed to do. And I have some test cases here. Okay, so this is important. If the input is 1, 2, 3 and a line feed character, then it will just go ahead and read 1, 2, 3, the 3 characters, and interpret it as the base 10 representation. So it's now going back to 123 and store that into the integer, and the subroutine should return it. Line feed is also going to be accepted in this case, or read in this case, because it is interpreted as a terminator of 1, 2, 3. 0.24 line feed is not going to work, okay? Because since I'm attempting to read a base 10 integer, a period or a point is not considered a valid beginning of a number. And as a result, it will attempt to read the period as the beginning of an integer, which will fail. And in that case, what your subroutine is supposed to do is it will dispose of the period, which basically just means read it and toss it away, and then reattempt to read the rest as an integer, which will be successful because 24 is an integer in base 2. It's in base 10. The line feed character you don't have to worry about, because it's a separator from the next number or whatever is coming next. Now, on the other hand, if this is the input, ASDF, and the end of file, then it's a little bit special and a little bit tricky, because you would read A and say, okay, this is not the starting point of a base 10 number, then you would dispose of it. Then the next digit you'll be reading is S, lowercase s, which is also not the beginning of a base 10 number. Dispose of it, dispose of this, and then guess what? Then you are at the end of the input file. So as far as readnum is concerned, there's no number to read in this case, but it has to go because you cannot read past end of file. As a result, if you hit end of file, even if you have not read a base 10 integer yet, you still have to go. Just say, well, don't use my return value, it is meaningless. The caller is responsible to check FEOF before making use of the return value of readnum, but readnum cannot do a single thing about it. Is that okay so far? All right. So to properly debug this program, you also should use a set of input files and test with your input files, and I'll talk about it during the lab time of today's lecture. Okay. So when you're all done, this is a usual, typical way to package everything up and turn it in. All right. So having said all of this stuff here, which I have no doubt a bunch is kind of confusing, like how do we do this, how do we do that? We'll go ahead and just write simple programs, okay? Each one to illustrate a particular point. Is that okay so far? Okay. So we'll start with scanf. reading a base 10 number. So we'll say read base 10. Okay, that's the name of this particular program. Include stdio.h, and I'll do everything in main, and all I'm going to do is to say I have an integer x, do a scanf, %d, which is the format string, and in this case, since I use %d as the format string to scanf, it's basically telling scanf, I want you to read in a base 10 number, and it has to be integer, and I want you to store that into the address of x. So in today's lab, I will also use GDB to help you kind of visualize the value of a variable as opposed to the address of a variable. Okay? But in this case, I'm just reading an integer from standard input file, put it into x, and that's it. That's all I'm going to do. And I'll just return 0 in this case. I'm all done. Yep.
Why do you have to put the %d in quotation marks?
Because it is a string. It is not. It is a string. It's basically a bunch of characters that I need to send to scanf.
Okay.
But I'm going to do a little bit more than this. Okay, I'm going to use y to store what scanf is returning. Because remember, I said you have to interpret the return value of scanf to see if there was a problem in the read operation. Okay, so I'm going to use this to illustrate that particular point. Okay, save the program, and now we can just go ahead and compile the program. Okay, same type of warning. That's okay. We'll let it go. Read base 10, read base 10.0, GDB read base 10. Put a breakpoint in main, and we just run the program. So we are just about to execute or run line 7 at this point. So I'll go ahead and just say, okay, let's continue the execution. But in this case, I want to put a breakpoint on line 8 because I do want to stop and take a look at what is in X and what is in Y. So we continue the execution of the program. And we'll just go ahead and specify 45 in this case. 45, press the enter key. Now I stop on line 8. What do you think is in X? X is supposed to be the variable storing the integer that I read from standard input file. Now in this case, since I did not use any redirection, the standard input file is just the keyboard or the console. It's whatever I type on the console. So what do you think should be in X at this point? 45. Yep. So X has a value of 45. What about Y? Y is storing the return value of scanf, and the return value of scanf is indicating how many things was successfully read in the previous attempt. Well, how many things did I even try to read? There was only one thing, right? One base 10 integer. Did I read a base 10 integer? Was there one to read? Yep, I read it into X. So Y is supposed to have value of what? Just one. Okay? I told scanf to read a base 10 integer. It read one single base 10 integer, and as a result, it returns a value of 1. Okay, let's double check. It is 1. Are we doing okay so far with this code?
So it returns a number of successful.
Right. Now there are some cases where you can combine, like you can have like 3 %Ds, %D space %D %D in the format string, which is basically telling scanf I need 3 integers. So in that case, the return value can be 0, which means you did not give it a single integer to read. It can be 1, which means it can read the first one, but the rest are not integers. It can return 2, can return 3 also. But in this case, since I only told it to read one single integer, the return value can either be a 0 or a 1. Cannot be anything else. Are we doing okay with this? Yes? No? Kind of? Okay. Let's go ahead and run the same program again. But this time I'll give it something that cannot be interpreted as an integer. So I'm going to give it ASDF. Press the enter key. What do you think should be in X? Well, does it even matter what is in X? The question is, can I look at ASDF, which is the content of the input file, as a base 10 integer? No, cannot, right? So that means nothing is really stored in X in this case. X is keeping its own garbage value from before. So if I print X, there's no point in doing it because it can be anything. Because it's garbage, okay? Scanf did not read a base 10 number, and as a result, it did not even touch the local variable X. What about Y? Should be a 0, because I did not even read a base 10 number, and as a result, scanf returned a 0, and that 0 was stored in local variable Y, and sure enough, we have a 0 in Y. That is your error detection, okay? Check the value of scanf, okay, the return value of scanf. If it is not the number of items that you wanted to read, there's a problem. Is that okay? Sort of? Yep.
So in this case, if you have an integer and scanf to be an integer, the bar always equals to 1.
When you call scanf with the format string of %d, if at that time the input file has an integer in base 10, then scanf will return a 1 and successfully read the content in the standard input file and store the value into whatever variable you specify or the address that you specify. Yep.
You use commas to separate each of the base 10 numbers, say if we find it.
You can, but then your input has to be separated by commas. Because it is not only, you're not only telling it that I'm trying to read 3 base 10 integers, you're also telling it that they have to be separated by commas. So if you specify 3 integers but not separated by commas, it will read the first one successfully, but then will fail the rest because it could not find the comma that it is expecting after the first integer. That's a good question.
So
But
if it was just like spaces between them?
if you specify a single space, it's going to be okay because I think with a single space, it can match any number of spaces. So you can.
So
Yep.
read it as one base 10 number.
Correct. Yep. That's a good question. We can actually test it too. That's a very good question. So we'll test it because it actually helps to illustrate the concept a little bit more. So in this case, we'll have several inputs. So we'll have x1, x2. 2 would be enough. And you're basically saying I want to read 2 integers. The first one into x1, the second one into x2. Is that kind of what you had in mind? So what if we specify 1 space 2 as the input? That would be the good question because I'm not using a comma as a separator. I'm using a space as a separator. So let's go ahead and test this one out. Okay. And I can type history to find out which command to repeat. So I want to repeat 509 and then 510. Go. And now we can go back into GDB, list the program, put a breakpoint on. I'm just going to put a breakpoint on line 8 because there's no real need to stop it on line 7, so I'm going to stop it on line 8. Run the program. The first time, I'll give it exactly what it wants, okay? So I'll give it like 12, 67, okay? So I am giving it 1 base 10 integer, and then a comma, and then another base 10 integer. Press the enter key. If everything works the way it's supposed to, x1 should be 12, x2 should be 67, and y should be 2. So that works out exactly the way we expected. Is that okay? Does this help illustrate what the return value of scanf is really doing? All right, let's run this program again. This time I'm going to give it something that is kind of what it wants, but not exactly what it wants. So this time when I run this program, I'll give it 1, 2, 12, and 67, but this time there's no comma to separate the two numbers. I use a space instead, okay? Press the enter key, and X1 should still be read correctly because there's nothing before that, so it would still be here. But X2 really should not be read correctly anymore because the comma is not there, so it will stop basically saying, okay, we are not, seeing the comma, so that's why it's still gibberish, it's still garbage from before. And when you print Y, it should report that we have only read one thing successfully. So that's a good question because it really helps to illustrate, the function of scanf.
So we lose the 67 then?
Sorry?
So we just lose the 67?
Nope, we're not losing it. The program has now stopped at a space character. So it's really just stopping at a space character and say, oh, I was expecting a comma here, but it's not a comma. I don't know what to do with this, and it will just stop there. So if you want to recover the error, you can basically say, okay, this is not what I'm expecting. I'll just go ahead and read it and dispose of it, and then keep going and see if I can actually find a comma later on. So you can do recovery that way. Are there any other questions about the program at this point? Particularly about how to use scanf for base 10 integers. Go ahead.
So the comma is the only valid.
No, you can use a space, you can use a semicolon, but whatever you specify in the format string is whatever it is expecting from the standard input file.
Where do you specify that?
Yep, I did.
Where?
In scanf. The format string of scanf is the one that specifies that. So in this particular case, see how I use a comma here? So that's why it is determined to find a comma after the first base 10 number, and the space doesn't cut it because a space is not a comma. Okay. Any other questions about this one? Yep. Mm-hmm.
What if we mix letters and numbers together?
Say again?
What if we mix letter and numbers together? Will it read the number?
It will read the first part of the number until the number is no more. Okay, let's go ahead and try that here. Okay, so I'm going to run the same program again. Okay, but this time I'll give it something like A1, 2, 3, ABC, like that. Okay, and then we'll even throw in this. Okay, which is completely irrelevant because when you think about this from the perspective of scanf, what is it expecting? It's expecting a base 10 number, a comma, and then another base 10 number, right? But what is it actually seeing? It's seeing a base 10 number, 1, 2, 3. It can parse. This is as far as it can go, interpreting the input as a base 10 number. As soon as it sees the lowercase a character, then we'll go like, uh-oh, this is not a base 10 number. I better stop now. So at that point, it has read successfully one single base 10 number, which is 1, 2, 3, but it couldn't even get to the comma, right? So in this case, x1 will have the value of 123. x2 cannot even get to 67, so it will still be uninitialized. And then the return value of scanf will be 1 because it was successfully able to read one single integer. But we'll go ahead and run it just to be sure. Press the enter key, print x1, it is 123. Print x2, it is uninitialized like last time. Print y, it is a 1 because scanf was only able to read one of the two things that we asked it to read. All right. All very good questions. Any other questions? Other questions? All right. If there are no other questions, I'm going to write another test program. Okay, so this is one piece of the puzzle that you need to understand. Okay, this is one chunk. The other chunk is scanf, but with %C as the format string instead of %D as the format string. So we want to see what %C is going to do. This one is kind of tricky because the standard input file to GDB, which is what you type as a command, is going to interfere with what you want to feed it to test the program. So I will illustrate why there's a problem here, and then I will also show you the solution to kind of bypass that problem, which is what you need. Well, I was originally scheduling to talk about that in the lab session. It's okay, I can move it, into the lecture portion because you need that anyway. Okay. So let's go ahead and read a character instead. So I call this readchar.cpp. And we'll go for something simple first, okay, and then we'll gradually turn this program into something that's more complex. So this time I have a single character called ch, okay, and we'll say int y, which is going to store the value of scanf here. %c instead of %d because I'm reading in a single character, not trying to read in multiple characters as a number. And we'll put it into ch, okay, which is a character, and return 0. Okay, this is almost the same thing as the original read number program, but reading a character instead. All right, so we'll go ahead and g++-g-c-wall readchar cpp. Same complaint as last time, not a problem. -o, which is the linker, and I want the output for the executable to be readchar, and the input is readchar.o, gdb readchar. We'll put a breakpoint on line 8, okay, because there's no point in stopping on line 7. On the program. Now, this time it's going to be kind of funny, because if I say 100 or 100 in the standard input file and then press the enter key, it doesn't really quite do this what I expect it to do, but that's okay. Okay, so the question now is, what is in ch? Now remember, this time I'm not asking to read a base 10 number. Okay, if I did ask for %d to specify I want to read the base 10 number, it would have read 100 and then come back with the value of 100 in whatever the second parameter is. But this time I only asked to read a single character. How many characters are here? 3. There are 3 characters with 1 line p character, which is implicit. So it's kind of 4, but but we can only see 3. There are only 3 printable characters. So 3 would be kind of correct. But how many characters did I ask to read? Only 1, right? So what do you think is in ch? 1, right? But which one? 1 as a digit or 1 as a value?
As a digit.
As a digit. Okay, what is the difference? I mean, what are we talking about here? There's only 1 1. Well, there's 1 1 as a digit, as a character, and there's 1 as a value 1. Okay, so this time we are reading in the character 1, not the value of 1. Okay, let's check. Okay, because we can check by seeing what is in ch. And in ch it says 49, and then in quotes, in single quotes, 1. What does that mean? It means, sorry, go ahead.
Is that ASCII code?
It is the ASCII code, exactly. So 49 is the base 10 ASCII code of the character 1. And that's why it also prints it out as quote 1 quote, because whenever it can be printed, it will represent it like this. So this means, this is important because it tells you that the character or the ASCII code of 1 is not the value 1. Yep.
So if you made like an integer variable x equals ch, would it be 49 or 1?
It'll be 49. It'll be 49 because ch is storing the ASCII code, but you can also look at it as an integer. That's a very good question. What about y? Y is still storing the number of things that I was able to read successfully. So in this case, how many things did I read successfully? 1, right? Because I asked for 1 single character, and I have at least 1 character in the input file. So y is saying, yeah, we got it. Are we still doing okay so far? Are there any questions about scanf using %d as opposed to %c as the format string? Because that really is the key part here, is changing the format string from %d, which is asking for a base 10 number, can be multi-digit base 10 number, to a %c, which is a single character, a single byte, which is a quantum of an input file. Does everybody understand what is a quantum? The smallest unit cannot be broken up into smaller chunks. We still doing okay? Yep, go ahead.
Can you explain the 49 and code 1?
Okay, the 49 is the base 10 representation of the ASCII code of 1. And because it is a character, so 49 is the ASCII code, 1 is the character that the ASCII code is representing. Okay, this boils down to what are you going to send to a printer in order for the printer to print out a digit 1? Okay, that is the question. What do you think? Okay, so think about this. Think about this a little bit. You have a computer here, and then you have a printer over here. Okay? And you want the printer to print out digits, punctuations, letters, and so on and so forth, right? Not just digits. Okay, fine. So if you want this to print out, let's say A1B, okay? What do you think would be the stream of zeros and ones to go to the printer in order to print A1B? Well, in this case, they have to understand the same language first, right? In other words, the computer and the printer, they have to at least implicitly agree on, okay, this is how we encode the lowercase letter a, this is how we encode the digit 1, and this is how we encode the letter b in lowercase. Is that making any sense? Because if they don't agree on the same standard, you know, the computer can send whatever over, and then the printer can misinterpret that stream of bits. Is that okay? So the standard, I'm going to use another terminal for this. So the standard is called ASCII. And you can understand ASCII by using its man page. Okay, ASCII stands for the American Standard Code for Information Interchange, which is nothing more than a big, huge lookup table. Okay, the lookup table is simply saying, what is the bit pattern representing that thing that I might want to send over to a printer? So when you look up this table, you can look up 1, 2, 3, 4, the digits. The digits are over here. Okay, so these are the digits from 0 to 9, and this is in hexadecimal. So you can see that 1 as a digit has a hexadecimal representation of 31, which is representing the bit stream that you need to send to the printer, so that the printer knows, oh, you want to print 1 on a piece of paper. Okay, and that bit stream, if you look at the actual binary representation, the 1 is 31, which is in binary. This is 0011 for the 3, 0001 for the 1. So this particular bit pattern is saying print the digit 1. Okay. What about lowercase a and lowercase b? Lowercase a is 97 in decimal, or 61 in hexadecimal. So the a is going to be 0110, which is the 6, 0001, which is the 1. So 61 is, this is lowercase a, this is the digit 1, and b is just one more than this, so the b is 0110, 0002. Now, of course, I'm writing this kind of backwards because this bit is actually transmitted first, and this bit, oops. I'm mixing bases here, not good. Okay, so this is, so b, once again, b is 01100010 because it's a base 2 number. So this bit here is the last bit to transmit in order to print A1B on a printer. Is that okay? But does everybody understand why, 1 as a value is not the same thing as 1 as a character? Okay. All right. Shall we proceed? Okay. So the next program that I'm going to write is going to illustrate end of file. Okay. Okay, so how do we know we are hitting end of file? So this is going to be an interesting program because you cannot test it using the traditional way of using GDB. You will have to use redirection in this case. So I'm going to write this program, that is going to test FEOF of end of file of something. So there we go. They all use standard input, standard IO.x, so the same header file will work for all of these programs. So in this case, I'm going to do this like int x here, okay, x equal to 0, and then I'll say, while it is not the end of file of standard in, these are all basically predefined, so you don't have to worry about the definition of any one of these. I want to do the following. If it's not the end of file, we'll go ahead and declare a local variable ch here. We'll say scanf %c will read one character at a time into ch. I don't even bother to take a look at what I just read. I just know that I read a character. That's all that I care. But for every single time I read a character, I'm also going to increase x by 1. Could have used ++ x, meaning exactly the same thing, because all I really care is x gets incremented. The value of the expression is not even used in this case, so it doesn't really matter. Okay, so what this program really is doing is counting the number of bytes or number of characters in a particular file, in the standard input file. Is that making any sense? Okay, let's just take a look at this program and see if you guys have any questions. Yep.
Could you just make something equal the scanf line to count instead of x++?
You can do the same thing here because we know that this is going to return 1, so you can just say add whatever scanf returns to x. So this would do exactly the same thing. Because if it is not the end of file, you're guaranteed that you have at least one more byte to read. Yep. Okay. Any other questions? Okay. Yep, go ahead.
How do we end the file, or how do we know if it's end of file?
That's a very good question. That's why this is an important program to evaluate. Because it's not just the program itself, but also how we test a program like this that's going to be important. I was originally thinking to put this into the lab session, but I'm going to move it ahead and do it here, just because it is kind of really important for the homework assignment. Okay. All right. So let's go ahead and get out of this program. Before we go any further, I'm going to demonstrate the cat program. Okay. Cat is actually concatenation. The only purpose of this program originally is to concatenate multiple input files into one single output file. That's all. Okay, that's the original purpose of the cat program. So it can take any number of input file and one single output file as a part of its quote-unquote arguments. But it can also be run all by itself, like this, okay, which is not very useful because what it does is it will just read the implicit input file, which is standard input file, and it will just copy everything from the implicit input file to the implicit output file. The implicit output file is standard output file, which is the console. So if I do it this way, I can type whatever, it just echoes back right away. Now, if I do something like this, how do I end it? Because cat, just like all the programs, like including the one that we are writing, is waiting for end of file. So if I keep typing, then it will say, oh, it's not end of file yet. We have to continue to wait for the input. So the only way you can specify, oh, this is it. This is the end of everything that I want to type, is Control D. Okay, so right now, when I press Control D on the keyboard, it ends the end of file, and then cat understands, oh, okay, this is all, and it will just exit. Okay. That means when you're testing your program, if you're doing the interactive mode, you have to do a Control D to specify this is the end of everything. Okay, I'm all done. The problem is when you type Control D in GDB, I think it also tells GDB that you're all done in GDB too. So you're not only done with the program that you're debugging, you're done with the GDB as well. So that might kick you out of GDB a little earlier than you want to. So we'll test it and see if that is the case. So what we'll do is we'll put a breakpoint on line 13 and then run the program, and all it's going to do is wait for me to type something, and it won't stop, right? Because it's not getting to the end of file. When I press Control D at this point, this is the question: is it going to kick me out of the program and also GDB at the same time? And there's okay, so it's not bad. It just ends the program without kicking me out of GDB. So now if I look at variable x, it should come back with the number of characters it has read. So it will be all the letters here, but we also have to count the implicit end of line characters, because the end of line characters are also characters. They're not printable, but they're nonetheless, they are still something that you have to send from the computer over to the printer. I'm done with this line. Do a line feed, go to the next line.
What about spaces?
Spaces are counted as characters as well. Space, all kinds of spaces. A tab, okay? A tab is counted as one character, even though it appears to be multiple. Punctuations, they're all counted as characters. So if I print X at this point, it shows that I have entered 54 characters. But this is not easy when you're testing your program, because you would probably want to test your program with all kinds of combinations of actual integers and non-integers and stuff like that. So the best way to do it is to put all the input into a test file and then feed the test file to your program using redirection. So this is what I will demonstrate next. Okay. So what you can do is you can set up a whole bunch of test input files. Not just one, but multiple, but I'm just going to show you how to set up one. So in this particular input file, I'll just specify this is a test of 2 lines. Okay, that's all I'm going to say here. Exit the program. But before I feed this program into the program, the first thing I'll do is to run WC to see that this particular input file has exactly 28 characters, because I want to check whether the program is counting to 28 as well. Okay, so this is something I want to test. And then what I'll do is to run this program, the program that we wrote before, FEOF, through GDB, like so, just like last time. Put a breakpoint on line 13, but this time when we run the program, we use the redirection symbol less than to basically say, instead of typing everything in as a standard input file, I'm going to be lazy this time. Instead, treat the content of test1.in as what I'm typing. Are we doing okay so far? This is called redirection. It's redirecting standard input file from the console, which is the quote-unquote default standard input file, to a particular file, which is test1.in in this case. Now, this is a really useful mechanism for testing your program, because you can set up a whole bunch of your test files, write the script just like before, and then each time you run your program, use a different redirection. So now we can basically just set it up to test all the special conditions that you can come up with. Okay, so I'm going to run the program, press the Enter key. It has finished reading everything in test1.in. It's time to print X, which counts the number of characters that has successfully read, and it's counting 27, not 28. It's missing 1 character. Now, if it is missing a character, I'm kind of curious which one it is missing. So what I'll do is I'm going to...
Is the end of file a character? Is the end of the file?
No, the end of file is not a character. It is just a condition. So when I press Control D on the keyboard, the Control D is not really read by the program as a character. It is simply a marker that I use to indicate this is the end. Okay. All right, so let's go ahead and check the program and see why it is missing 1 single character. All right, so how do we test it? We put a breakpoint on line 11. And obviously, I don't want the input file to be that long, because that would just take a whole bunch of steps to do it. So instead, this is another trick. Whether you want to do it or not, it's up to you. I don't want to have to get back into Bash to create a file and then use that file to test the input. So the exclamation point in GDB does not mean logical not. It means I want to go to the Bash and do something and come back to GDB. Okay, which is a really cool feature because it gives you the ability to not to have to exit GDB when you're in the middle of something, but yet you can run a shell command and just come back later. So in this case, I'm going to shell out, do a vim of test2.in, which is going to be a simplified file, which only has A, B, 2 lines. Okay, so this file has 4 characters: A, line feed, B, line feed. So it should have 4 characters. Okay. Colon X to save the file and exit. And I can shout out again, and this time I run wc word count on test2.in, and surely it has 2 lines, 2 words, and 4 characters, which is the way I expected. Now we rerun the program, but this time I have a breakpoint on line 11 already, so every time I do a scanf, it will, that breakpoint may not be very helpful. We'll see. Okay. Test2.in. Yes, okay, single step. It's single stepping into scanf, which is not what I want. Okay, we'll do a continue first, and then there's a way to step over. I cannot remember. Okay, no. Next. Okay, there we go. So the command is next. All right, there we go. So I can say print ch. Okay, this won't work. Because ch is defined within the scope. Every time I get out of that statement, it will it's automatically out of scope already. So that doesn't give me any choice. I have to get out of the program and actually, change the program a little bit itself. I have to move it up here, so this way, ch gets accessible from outside of the scope of the loop. So this way, actually, I can read the last character, which is the only one that I care about. In the amount of time to find out which command to repeat, I could have just typed the command itself. Put a breakpoint on line 13, run the program again, this time using test2.in, and I want to know what is the last character that it read. It was 10. It was 10, which is the line feed character. But what about X? It is only counting as 3. First one is A, line feed, B, and then a line feed. And each time it should increase by 1. It's not doing what I expected to do. So we'll go ahead and do this again. Next, print ch. The first one it read is A, and X is 1 at this point. Continue, next. Then it reads the first line feed character of the first line. It counts to 2. Continue again. Print ch. Oh, next first. Print ch is reading B. Print the count, it is now 3. Continue again. Next. Print ch. It is the line feed character. Print X, it is 4. Continue, and this time it cannot read anything, so X should not increment anymore. It's returning a -1, that's why. It's returning -4 because it is end of file. That's why. Okay. So it's time to get back to the man page. Man scanf. And go back to the return value section because I did not read the whole thing.
Yeah.
I read the first paragraph, but not the second one. And this is when I will talk to there'll be a little bit of serious self-talking happening right now, and it can be abbreviated to 4 letters, RTFM. Okay, it happens to everyone. Okay, there are the RTFM moment happens to everyone, especially in programming. The second paragraph says what? The value EOF is returned if the end of the input is reached before either the first successful conversion or matching failure occurs. EOF is also returned if a read error occurs, in which case the error indicator in the stream is set and error num is set indicating the error. But EOF as a value is -1. And that's why it read all the way up to 4, and since the last scanf, which is attempting to read past end of file, returns a -1, and I'm just adding it to X, it rolled back to 3, and that's why it's like, how come it's not adding up? That's why.
It's my fault.
No, it's my fault not reading the man page entirely, in its entirety. So use this as a lesson to you and say, well, whenever you read the manual, make sure that you read the whole thing. Happens a lot with me, I just read a part of the manual and go, okay, I think I know what it is. All right. So with that, those are all the pieces that you need to write your program, okay? Each one is only a piece, okay? But you have to combine all of these pieces to kind of do it. Now, what I recommend you to do is something like this. Okay, so I want you to do this. Use the same concept of an input file, but you don't even need to do that. I want you to do a scanf, using %d with an integer. You can always store the return value because that's really useful, but in this case it's not that useful. And do a %c into a ch. Now obviously you have to declare local variable x and local variable ch to get it to work. And then have these two statements in a sequence right next to each other. The input I want you to present to it is 1, 2, 3, and say x here. Okay, so in this case, 1, 2, 3, which is 123 as a value, should be stored in x, which is implicitly an integer, and ch should get the ASCII code of x. Is that okay? Because this is really important, because it is not the solution to your homework assignment, but it illustrates something that is important to get your homework assignment to work. All right, so we're going to take a break here. We'll take a 10-minute break. We'll come back at 10:33, and when we come back, I will illustrate what is the concept of an address in GDB, and we'll see if there are any additional demonstrations that you might want to see for the homework assignment. Start the recorder.
Uncle Walker.